Hi, my name's Stewart Lynch, and this is the second video in my introduction to the SwiftUI Charts framework that was introduced in iOS 16. In this video, I'll take a look at how we can better present large data sets of data to your users by way of bar charts. This is a particularly long video, and there is no need to watch it all the way through in one sitting. I have chapter links in the video, so take your time. If you've not already watched the first video in this series, I suggest that you do. As in that video, I go through in detail how the Charts framework implements bar charts. It uses the same starter project as this one, and you can find a link in the description. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. So the first thing that you need to do is to understand the data structure for this app. If you open the models folder for the starter project, you'll see that I have my models. The primary one for our first two examples is the wine model, and it's simply a struct that conforms to the identifiable protocol and has three other properties: the number of bottles in stock, the variety, which is of type variety, and winery, which is of type winery. So let's take a look at those two structs. Variety has a name and a wine type, which is an enum that I'll show you shortly. Winery is basically the same, only it has a name property. The models all are codable and have an ID property because I will be populating the wine's variety and the winery's properties on import. So I use the property ID for those two structs in a JSON file to do that. That's not really important for this video. The log entry struct is another identifiable object that is used to record when I add or remove a wine from my cellar. It has the wine that is being added or removed, along with the date and an action, which is another enum that will represent whether it is in or out, and another property, which is the quantity. I have added a computed property called date components that will allow me to extract the month, day, and year from my date, and thus be able to easily group entries by month. So here's that enum file, and as you can see, there is the action for in and out, and the wine type can be any one of these 6 different types of wines, plus one for unknown. Year is another enum that just lists the 2 years that are available in my log entries import, and it is case iterable so that we can use it to present a picker. The data store is an observable object that holds the arrays of all of our data. The seed data function loads the data from the wine data JSON file. And it imports into this import struct, where I'll be able to map properties to my models. And then in the seed data function, I go about finding the matches by ID to populate the published properties of arrays. I use this technique a lot for backing up and restoring data from my apps. And this is a direct custom export from my own wine cellar app. The data store object itself gets initialized at app entry, and the initializer sees the data and gets it injected into the environment for my tab view. I then use the log entries from the data store to pass into the wine list view, and its array of log entry, and I'll use a wine log view model to present the information in the list. There's a picker that will allow me to choose what year I want to display. When the view appears, I call a setup function on my view model that passes in all of the log entries so that I can work with them in that view model. The wine list view model has a published property that will be used by the picker to switch years, and then I have a filtered log function that I can use to filter the logs based on the year and sort them using a key path comparator by date. At the top of my wine list view, I also display the number of wines that I've logged in and out for the filtered array by filtering further on the action mapping the quantity into an array that I sum up using the reduce function. And I can calculate the current inventory count for that year by subtracting those two values. So that's how I display that list. It does not, however, give me a very good understanding of what I have in my cellar. So let's take a look at what I can do to solve that problem. In our first example, I want to determine how many varieties of each type that I have in stock. Now I currently have a placeholder file for the types chart view that is nothing more than a navigation stack with a title and a placeholder vstack where I can place my chart. I want to create a view model to handle the logic for this view, and that view model is going to have access to all of my wines. And I'll get those wines from the data store that's available in the tab view. So I'm going to create a new property in the types bar chart view called wines, and it's an array of wine. And then in the preview, I can add in the property by creating an instance of the data store to access the wines property. Now in the Start tab, where we present the tabs chart view, I'll pass in the wines from the store. So now we can create our view model for this view. And I'll create a new file called charts view model. And inside there, I'm going to create a new class of the same name, and it'll conform to the observable object protocol. This view will receive our wines from the view, but initially it doesn't exist. So we'll create a publish property that is an optional array of wine. Now I can create a setup function that will have one parameter for wines, and it will get passed in from the view, and we'll assign it to the wines property. So I'll need to now return to the types bar chart view and create an instance of our new view model that will be a state object. And then when this view appears, I'll create an onAppear modifier where I can call that view model's setup function by passing in that array of wines. Now I'm going to be creating a bar chart that's going to have to know the name and number of wines in stock from our array of wines. And since we will be iterating through the wines, I'd like to have a struct that is identifiable. So I'm going to create a new struct called bar entry, and it will conform to the identifiable protocol. And I'm going to create two properties, name, which will be a string, and in stock, which is an int. And I can create this inside the view model as it will not be used anywhere else. Now to conform to the identifiable protocol, I'll create a new ID property of type string as a computed property, and it'll simply be the name property. And this corresponds to the raw value of the wine's variety type. Now I can create a computed property that will be an array of all of these entries that I can create by mapping the corresponding properties from the wines array. But first we have to check to see if we actually have wines, so we'll use flet, else I'm going to return an empty array. And then we create our bar entry by mapping from wines and creating a bar entry where the name is the iterator's variety wine type raw value, and the in stock will be the iterator's in stock value. Well, now that we have an array of all these entries, I want to group them by the name property. And I can do so by using the dictionary's grouping functions to create a dictionary that will be a string key, and it will have an array of bar entry. So the dictionary is found by grouping all entries by $0.name. The grouping dictionary itself is not that useful to us right now because at this point we don't need to know all of the bar entries. I just want to take the name from one of them and find all of the bar entries that use that name, and then total the number in stock, and that will be my single cumulative bar entry for that entire array. So this can be a computed property that I will call groupings, And it'll be an array of these single cumulative ones for each type. So I'll start with an empty array that I'll call groupings. Then I'll use a for each loop on the keys and values in our dictionary grouping. I can then generate the total by reducing the entries array by starting at 0 and then adding in the stock value for each one thereafter. Once I have that, I can then append a single new instance of a bar entry using that name from our grouping and then using the total that's in stock. Now there may be some wine types that I'm out of, so I don't want to display them. So I can then filter them out by only getting the ones that were in stock, which is greater than 0. And then as well, as I'm returning, I can sort them using the key path comparator on the name key path. So that gives us everything we need to create the bar chart. The types bar chart already has the charts framework imported. I'm going to leave the VStack as is for now, as I want to add a list view below the chart. So with this VStack, I'm going to create a new chart object that will iterate over our view model's computed groupings. And it will provide us with a bar entry. We can then create a bar mark, and we'll want the quantitative value to be the y-axis, a vertical. So we'll use for the x the value where the string will be wine type and the actual value will be the bar entry's name. And then for the y value, it'll be in stock and the value will be the bar entry in stock. Let's use a foreground style by the wine type property, which is the bar entry name. Now to create room for our list below, I'm going to add a chart plot style modifier that'll give us access to the plot area. We can then set the plot area to be a height of 200, and then I can set a background color that we'll specify as the secondary system background. Let's also add some padding to our chart. And then because we don't really need to have this legend here, I can hide it using the chart legend hidden. So now we have this chart presented with nice colors and nicely labeled. What we want to be able to do now is to be able to tap on one of these bars to display a list of all of the wines of that type in a list below the bar. So I'll want to present the variety name, the winery, and the number in stock. So we're going to need to have a selected wine property in our view model. So this will be an optional because when the view loads, no wine will be selected. So it's an optional wine type. Now I can create another computed property that will filter out all of the wines of this type that are in stock. First, we check to see if we have wines and a selected item, else we'll return an empty array. Now if we have our wines and one is selected, we can do our filtering where we match the iterator's variety wine type with the selected type and ensure that its stock is greater than 0. And we can also use the sort key path comparator operator to sort by the variety name. Back in Charts view, we can add a tap gesture to the bar, and we do that by accessing the chart overlay. Now this provides us with a proxy that will give us access to the frame for our bars. We can then set up a geometry reader that provides us with another proxy that we'll call nth geoitem. And I'll create a rectangle over the entire chart using a fill of clear and a content shape of rectangle. Now that I have that rectangle, we can add an on-tap gesture to determine where that tap location is with respect to the proxy. And we can let this value be x, and it will be equal to the tap gesture's value at the X position minus the nth GeoItems proxy plot areas frame origin X value. Now, our wine type will be an optional string that will be equal to the proxy value at X for that X value. We can then unwrap this then and assign the wine type, whose raw value is that string, to the view model's selected types. With that now we can add a spacer after the overlay to push the chart up to the top and create a list that will iterate over the view model's selected type wines. We'll create an H stack, and for the first item I'll present a text view displaying the wine's variety name and then set it to bold. I'll add a spacer to push this next text view to the right, and it will display what's in stock. And let's give it a headline font. Now let's embed this itself into a VStack. And then for the second item in the VStack, we can add the winery name in a text view. And let me set the list style to plain. Let me test. Almost. I don't like this display, so let me go back and set the alignment of the VStack to leading. Testing now. That's exactly what I want. Okay, stick with me then. If you're still interested, I've got 2 more sets of charts to do, and each one is different. For our next view, we're going to allow the user to select from either wineries or varieties to see what the current count is. There are 135 different wineries and 111 different varieties in this data set. So we'll have to be careful how we present this information in a bar chart. The good news is that we can reuse our charts view model with just a couple of extra modifications. Within the charts view model, create an enum called chart type that has a string raw value, is case iterable, and identifiable. The cases will be wineries, varieties, and because we want to use this for our existing chart, we'll need to include types. Then the ID is a computed property that's a string that will just be the raw value of the case. When we generate our all entries array, we'll need to return a different array based on a chart type. So first, we'll create a publish property called chart type that is of this new type chart type, and we'll give it types as the default. In the all entries computed property after the if let, I'm going to create a switch on the chart type. Where the case is types, we'll return what we already have. Where the case is wineries, we'll map the winery name instead. And then in the case of varieties, we'll map the variety name. Now whenever we come back to this view and it appears, we want to present the types bar chart view. So we'll need to go back to our charts view and assign types to this chart type when that view loads. So now we can go to the groupings chart view. And we're going to start the same way as we did in the previous view by getting the wines when we present this view. So I'll need to create a property called wines that will be an array of wine. And make sure that we add the data store wines to the preview. And then I can create another instance of our view model as a state object. In the onAppear function, we can call the setup function again, passing in those wines. And then we can pick one of our chart types. So let's just pick wineries and set that. Of course, we have to get that initial set of wines, and we do that from the Start tab view. So we'll pass the wine forward from the data store into this view. Well, let's be a little creative here in our layout. So within the navigation stack, I'm going to create a list. And that list is going to have two sections. One for the chart and another for a picker that's going to allow us to choose whether we want to display wineries or varieties. So let's create the list and two sections now. And we'll focus on the picker first, which will be the second section. In the first section, I'm just going to add a text view that I will give the string in stock. In the second section, I'll create a picker with the string category, and the selection will be the view models chart type. I can then create a for each loop on the chart view models chart type enums all cases. And it has three choices, but I only want to see two. So I'll drop the last one, which is types. And that will give us one of the two categories, either being wineries or varieties. Then we create a text view that displays that category's raw value, and I can capitalize it and set the tag to this category. And we can change this picker style to be segmented. Next, I can change the navigation title based on that chart type and make sure we capitalize it as well. I can see it's functional now. Tapping on this segmented picker, it changes the actual title of our view. What we have to do now in this first section is to create the chart. So for that chart, let's use a view model groupings to iterate over within our chart. Now I want this to be a horizontal bar chart, so the quantitative data, the in-stock value, must be on the x-axis. And the grouping name will be the y value. Unfortunately, this crunches up all of the bars on the top of the chart. What I've discovered is that I can embed the chart in a vertical scroll view and set the frame of the scroll view to a specific height and specify the chart itself to a specific height. So I can adjust the frame of the bar chart then within that scroll view, and in order to do that, we'll need to know the parent scroll view's frame height. So create a property called frame height and assign it the double value 400.0. Now let's embed the chart then in a scroll view that will be vertical, and then set the frame height of that scroll view to the frame height property. Next then we can use the chart plot style modifier to get access to the plot area, and we can set the frame height. Now it's a CG float where we can multiply the frame height by the count of the items in our groupings. But since this is an int, I'll need to convert it to a double first so that we can multiply it to the frame height, which is a double. Now this gives us rather large bars, but I can divide it by 10, and now it's reasonable. There's no magic to this. I just tested a bunch of different formulas, and I find that this one gives me a reasonable width bars no matter how many items there are in our groupings array. This now gives us a scrolling view with reasonably heighted bars. Now, since the bottom of the chart is below the view frame when I first load my data, I don't see what the scale is. So I want to move the x-axis label to the top. And I can do this with a chart axis modifier. And then for the axis marks, let's preset it to be automatic, but set the position to top. Now, I'd really like to see the numbers as I scroll, because once I start scrolling, I lose that x-axis. So I can do one more thing. I can add an annotation to each of the bars to get that. I'll want the position to be trailing. And then I can present a text view displaying that grouping's in stock number. And I'll reduce the size by setting the font to a caption size. And there you have it. I have a nice scrolling list that shows me how many of each of the wines from the different wineries I have in stock. Or I can switch to see a list of varieties and see how many wines of each variety I have. You might want to take a breather and come back to this one. Remember, I have the sections in the description that will take you directly to each example. If you're still with me then, in our in-out view, we'll be looking at our log entries and not our wines. So we'll need a new view model for this view. But first we'll need to be able to pass in the array of log entries from our store via our tab view to our in-out bar chart view. So let's create a new variable called log entries that will be an array of log entry. And of course, we'll need to add the data store's log entries to the preview too. And then we can go back to the Start tab and pass that in from the store. So now let me create a new view model file, and I'm going to call it in-out view model. Within there, I'm going to create a class with the same name, making sure that it conforms to the Observable Object Protocol. I'll add that publish property now that will be our log entries, and it will be an optional array of log entry. Now, you may recall that I had another enum that was called year with two cases, year 1 and year 2, along with the all cases. And the values are the 2 years that I have my logs. So I'm going to create another publish property here for the year, and I'm going to assign it year 1. And this will allow me to create a picker to go from all years, year 1, year 2, to take a look at the number of log entries I have. Now, as we did when we first created our charts view model, the very first one, I'm going to create a setup function that will take in an array of log entries and then assign it to the log entries publish property. So back in our view then, we can create an instance of the view model, and that's going to be a state object. And then within the onAppear, then we can call our setup function when the view appears and set the year to year 1 each time this view comes in play. Returning then to the view model, we'll first need to create a computed property that will extract the array of all the log entries for a given year. And we can use an if-let then to unwrap the optional log entries, and if it has not yet been populated, we'll return an empty array. We can then switch on that particular year. In the case where we want all logs, we'll just return the entire array of log entries. And we'll sort by the key path date. In the other two cases then, we can use the default, and then we'll return the log entries where we'll filter on the date component's year, where it's equal to the integer value of our year's raw value. And again, we'll sort the same way. Just as we had a bar entry in our previous view, we're going to need to create a model for our bar charts and our marks here. Now this one's a bit more involved because we want to be able to display wines in differently from wines out. So I'm going to create a new struct called monthly log, and again it will be identifiable. And for that property I'll just create a UUID. So I'll need a month, which will be an int, and we'll need to know if it's either in or out of my cellar. And that's one of those action types. So we have that enum for it. And we'll also need to know the quantity. And then for display purposes, I want the actual value that will be a computed int. If the action is in, we'll return the negative quantity. Otherwise, the positive quantity. And I also want to display the month name for our date component. Now, there might be some fancy way of doing this from a calendar function, but I'm just going to be lazy here and switch on the month int and return the corresponding 3-letter string for that int corresponding to the month. Next, as in the last example, we group the log entries by month by creating a dictionary, but this time it's of type int for the key and an array of log entries for the values. And then using the dictionary's grouping construct, we can group on the filtered logs by the date component's month property and unwrap it. So each month is going to have its own array of log entries. Well, now we can generate the array of our monthly log entries that we'll be using for our bar marks by going through our group dictionary. So we'll start first by creating an empty array. Then we'll iterate over the monthly logs key value pairs in the group by month dictionary. We can let the wines in be the logs that are filtered where the action is in. We'll create a property called quantity in that we can find by reducing the wines in array, starting at 0, and then adding in the quantity to each subsequent entry. And when we have that, we can then append to our all logs a new instance of the monthly log, passing in the month, which is our key, and the action for this one will be in, and the quantity will be that computed quantity in. I can then just copy these lines then and change it to generate the wines out item and append it. Then finally we return all logs and make sure that we'll sort using the month key path comparator. Well, we can finally create our last chart using this information from our view model. Now this will be similar to the last one in that we want to have a scrolling chart, but this time it will be horizontal. So first I'm going to create a state object that I'm going to call scroll width that will be a double, and we'll set it to be 450. Inside the navigation stack, I'm going to create a list again with 2 sections. Let me leave the first section for now, but in the second section, I'm going to create a picker where the string is year, and we'll bind it to the view model's year property. Then we can use a for each loop on the year's all cases, where the ID is self to give us the year iterator. Then we can create a text view with that year's raw value, and the tag will be that year itself. And then to create a segmented picker, we'll change the style. Below the picker, I'm going to create a slider, but first I want a text view. So I'm going to create a VStack where I'll set the alignment to leading. Then I'm going to create a text view that will tell me what my scroll view width is. So we'll need a string, and then we'll use string interpolation to have the scroll width printed, but I'll specify that we don't want any decimal point. So the specifier will be the quotes %.0f. Next, we're going to create a slider where the value will be bound to the scroll width, but we'll restrict it to be within the range of 450 to 1600. So we'll start at 450. Now the label, we can assign it scroll view width. The minimum value label will just be a text view with 450. And similarly, the maximum one will be another text view using the string 1600. Now this will allow us to adjust the width of our bars by sliding this slider back and forth. So let's work on our chart. Again, we'll start with the scroll view, but this time the direction is going to be horizontal. Then we create a chart using the view model's all logs that'll provide us with the log iterator, and we can use that to create a bar mark. Now we want this to be a vertical chart scrolling horizontally, where the quantitative value will be the y value. And we'll use the actual value, that positive or negative quantity. And then for the x, instead of using the integer value for the month, we'll use that computed string, the month. Now this frame is way too compressed, so we can get access to the plot area, again using the chart plot style modifier. And then we can set the frame on the plot area by setting the width to our scroll width, and then provide a height of 350. I'd like to know the actual values that we're seeing here, so I'm going to create an annotation for each bar. Now the position will change, though, depending on whether I'm above or below 0, meaning in or out. So if the log action is in, we'll set the position of our annotation to the top, else it will be on the bottom. And then we can specify the annotation as being a text view using the log's actual value, the positive or negative, and then apply a caption font. I'd like to make this a little more distinct here so that I can actually see the pluses and minuses, so I want to change the colors. I'll set the single foreground style here to something like green, and that changes both. But I can make it conditional based on the action again. So if the action is in, I'll make it purple. Otherwise, we'll make it green. Now I want to do one more thing, and that's a rule mark. A rule mark will set a line wherever we specify. And I want this to be horizontally running up the y-axis to show me when I'm getting in a danger zone of drinking too much, too many wines out. So it takes a plottable value. And we can specify that danger zone for screen readers and set a value of -25. So let's set a line style to be a stroke style of a dash with a width of 15 and a spacing of 5 in between. It's dangerous, so let's set the foreground style to be red. But I'll also create an annotation for the rule mark. And I want that to be positioned below the line, so we'll choose bottom. And I'm also wanting it to be on the leading edge, so I'll set an alignment of a leading edge. And then for the annotation itself, I'll just create a text view with that same string, danger zone. And I'll apply a headline font. And let's match the color by setting the foreground color to red. I can see that now. I can scroll left and right. I can change the year. And I can adjust the width of the bar, all the time seeing which months I was in my danger zone. If I run this in the simulator now, I get to see my app in dark mode here. I can use the tab view to switch between all three of my different charts and make much more sense of that data. Now, this has been a pretty long video, even by my standards, but those of you who made it through, I hope you find that you've gained some knowledge so that you'll be able to add charts to your own apps whenever you want to present information to your users in a graphical way. Thank you so much for watching.